Okay, so what we have now, starting back up, here is our data points. These are the actual numbers that happened. This is how much was actually spent each year, each of these years on Social Security. This is a new equation for Excel using 1975 as year zero. Now notice it still has a negative number. That's because it took the line of best fit. It didn't just take the first and last data points like we did. So it took the line of best fit, and the line of best fit's going to show zero down here, maybe 1974, 1973. So there's our line, and there is this is still 1975 equals year zero here too. So they both have 1975 as year zero. So now we're going to extrapolate. We're going to look at what both of these models project will be spent in 2020. So this model here and this model here. And to do that, we're going to put in how many years 2020 is since 1975, which is just 45 years. And I'm going to put 45 years in here. And now I'm just going to pause this and do this math. Okay, so we put the 45 in for X, which is years since 1975, and for our model, which we used the first and last data point, we get a projection of 1,007,750 millions, which would be actually just over $1 trillion. And for the model that Excel generated, the line of best fit, the blue line, we got 908,000 millions, which is just 0.9 trillions. So the actual number was 1.092 million, which is 1.092 trillion, which this was our model using the first and last data points, was more accurate than the best fit line generated by Excel. You wouldn't think that, but what we were able to do was capture some of this increasing momentum, increasing spending in the last 10 or 15 years. And Excel just took these as part of the entire data set, but the trend is starting to more and more money is being spent. And the reason for that is because the baby boomers are retiring in mass. Our last objective here is on extrapolation versus interpolation. Extrapolation is the process of making a prediction using a trend line outside the domain of inputs for the scatter plot. In other words, when we did with Social Security, we looked at some data that was predicting outside of the range that we had data for, and that's an extrapolation. An interpolation is just making a prediction within the data that we had. So if we didn't have an exact data point, say for Social Security in 1982, finding that number would be an interpolation. So we're just going to look a little bit at divorce rates, and here is divorce rates, and here's 2004, and these are a number of divorces, etc. And here's some rates. And we're going to pick one of these rates to dive into a little bit more. So this one here, this 3.8, that means there was 3.8 divorces in that year per 1,000 people in the population. This means there was 7.8 divorces that year for every 1,000 marriages in the population. This means that there was almost half, 48.7 divorces for every 100 marriages that year. And finally, in the 19.3 means there was 19.3 divorces for every 1,000 marriages in the entire population. Now, we're going to use this one because this one here, it gives, you're only comparing the denominator is just people married that year, where the numerator is all marriages that ended in divorce over the entire country. So this is a misleading number here. This one. So we're going to use this number. So this is, we're going to look at the divorces per 1,000 marriages total in the population. And here's the trend line for all the data. And there's the equation that Excel generated. Again, we're using the year 0 as starting point. So this negative slope, this negative y-intercept is really meaningless. But the slope is not. And just to interpret the slope, it means that the number of divorces over here, y, right, per 1,000 in the marriage has been increasing by 0.1408 per year. Divorces per year. Now, what's happened since 1980? It's gone down sharp, a huge leap, and then it started dropping down all the way to 2020. And why is that? Well, here is an explanation. We could explain the divorce rate started falling after 1980. Fewer divorces. That could be. There could actually be more divorces, though, however, if the marriage rate of the population is increasing. But it's not. Marriage rates are also falling, so living together and having more babies out of wedlock become more socially acceptable. So you really can't get divorced if you're not married. You never bothered to marry in the first place, you're not going to get divorced. So they think that's what's happening, and this kind of shows that. Living arrangements of the American adult age 18 to 24, living with a spouse has been decreasing all the way since 1968, and living with a partner has been increasing. And then finally, about 2008 here, you have more people living together and not married than living with in marriage. So it's hard for these people to get divorced if they never got married, which explains why the divorce rate is decreasing.